Okay, now let's look at some of the examples. Okay, this one way fgx into the f is to the gx equal to f function to this x plus 3, and this x is replaced by gx 1 minus x, so it's 2 plus 3 minus 2x, so 5 minus 2x. Okay, now let's look at number 4. Number 4, find f g x gx is function f x base x squared. The x is replaced with the gx, which is 2 minus x. Okay, now we're supposed to find the domain and the range of fg. Okay, now can you substitute any value here? X, any problem by substitute x? Is there any x value whereby if I put it in, you end up infinity for the composite function value? Okay, then if you look at this, you can substitute any x value. It's very, okay. You can put any value without creating infinity and then undefined. Okay. So the domain in this case x can be any real value. Okay, what about range? Is something. Range means the value of the composite function. Okay, this is something interesting. Now, because of the presence of the square here, whatever value obtained inside will still be positive. You can put x equal to 5, 2 minus 5, become minus 3. Your square is still positive. Okay? So first thing is, the notice is fg x, okay, has to be positive. Okay, it has to be positive. Now, let's talk about the value of x. When x is equal to 2, what happened to the base? This base to the power of 2. It becomes 0. Square 0 still gives you 0. If you substitute any x value inside, you end up a number that is bigger than 0. It could be smaller than 0, but once you square it, it will be bigger than 0. Okay, so let's sketch the graph. Okay, sketch the graph first. What I mean is this. Okay, now x can be any value, but y can never be negative. Okay, and what is the minimum value of y? If let's say that fgx equal to y, okay, y, Okay, when x go to 2, this whole thing becomes 0. So 0 squared 0 is still 0. So when x go to 2, y value is, when it's 2, y value is 0. So remember this to the power of 2. Hello. This to the power of 2 here. To the power of 2, so it's a quadratic function. Okay. So you should expect to see this curve here. Okay. So this is the answer. Now, what about g of x? So, I haven't. Okay. Therefore, the range for this, for the y value, y will be, it can be equal to 0 when x equal to 2, it can become a 0. Okay, but other than that, it's bigger than 0. Why? Because of the square here. So it's bigger than 0. Y equal to 0 or bigger than 0. Now, let's get the other part here. Question 4, so gx, gf now. So this one is equal to 2 minus the bracket here. This is x. Now it's substitute by fx. Fx function is x squared. Okay. Okay, look at this. What is the? Is there any x value which give a gf value infinity or undefined? You can substitute any x value. Okay, so in this case, the domain is still x, any value of your number. Now let's look at the composite function. 2 minus. Okay. Now remember, this can be rearranged like minus x squared plus 2. You have a minus in front of the x2. This is a curve, a maximum curve. Okay, so maximum curve. When they pass through, the y-intercept 2. Okay, we'll draw this. Now, you can see that if you look at using the completing the square, okay, you look at it, this is actually in a format of completing the square. Now, what do you mean? It's actually minus x minus 0 square plus 2. Okay. The maximum of y value it can go is 2. Okay. If you use you look at it from completing the square. Okay. When will this happen? Is when x goes to 0. Okay. So basically, if you use completing the square. Okay. So